Okay, so I'm recording this conversation about the homework 2 question 4. Well, just in case some others, this may help some other students. So let me first talk about a basic idea on how we do the proofs. Say if we have one guy and this guy is Dr. Sung, and then we have another guy, and let's assume that this guy is Bob. Okay, so I'm just drawing those two figures. And what we want to prove is Dr. Sung is heavier than Bob. And then how do we do that? Well, of course, if you can have my weight and Bob's weight, and then you can prove that Dr. Sung is fatter or heavier than Bob. But what if we don't want to release this information? And what can I do? And then, well, we can draw a bar, and then we do a support point right in the middle. And then have Dr. Sung standing on one side, Bob standing on the other side, and whichever heavier will go lower, and then the lighter one will go higher, right? So this is the idea. If we want to prove that Dr. Sung is heavier, what we can do is, if we do Dr. Sung minus 1 pound, is still heavier than Bob. This means Dr. Sung is heavier than Bob, guaranteed. Because even we take 1 pound from Dr. Sung is still heavier than Bob, right? Okay, and another thing we can do is, let me first erase this minus 1 pound. Let's do another one. Let's add 1 pound to Bob. So if we add 1 pound to Bob, but still Dr. Sung is heavier than Bob, what does this mean? Even I add 1 pound to Bob, Bob is still lighter than me. So this means I am heavier than Bob, right? So this shows the trick that we are going to use in this induction. So let's talk about the induction. We are trying to prove that k plus 1 factorial is greater than k plus 1 cubed, right? So to prove this, if we take out a k plus 1 from both sides, this is equivalent to prove k factorial is greater than, is greater than k plus 1 squared. So we are canceling a k plus 1 on both sides, right? So this is what we have. And then if we want to break this, this equals k squared and then plus 2k plus 1, right? So this equivalents to, we want to prove k factorial is greater than k squared plus 2k plus 1. Now we want to add 1 pound to Bob. We want to make the right part larger, but still we can prove that k factorial is smaller than that. So how do we do that? So we want to copy this. I want to increase the right side. I want to change this k to k squared. I want to change this 1 to 1k squared. Okay? I'm increasing this 2k to 2k squared. So k is a positive value greater than 1. So I'm increasing this term from 2k to 2k squared. And then for this 1, I'm increasing this 1 to 1k squared. So this is even bigger increase. So I'm adding things to Bob. But still, I will be able to prove that I'm heavier than Bob. Okay, so if you want to add those three terms together, that is 4k squared. Okay, so this is equivalent to prove k factorial is greater than 4k squared. So what's the cool thing on this part? B can cancel a k on both sides. So if you cancel this k and cancel this k, and this becomes, this is equivalent to prove k minus 1 factorial is greater than 4k. So are you still with me? Okay. Okay. So now I want to prove this. I want to do a -1 pound on Dr. Song. So I want to make Dr. Song smaller, but still I will be able to prove I'm making Dr. Song smaller. I'm also making Bob bigger, but still Dr. Song is heavier than Bob. Okay, so the trick I did is I'm gonna only take the first two terms. So this is k minus 1, k minus 2, and k minus 3 factorial is greater than 4k. But I'm going to drop this k minus 1 factorial. I only want to prove that the first two terms combined together is going to be bigger than 4k already. Okay, so and how do I do this? What I want to do is I want to break those into several terms. So this on the left side, I'm going to have k squared, and then minus 3k, and then plus a 2 is greater than 4k. Okay, now I have a positive term 2 here. I'm going to minus 2 on Dr. Song's side. So I'm dropping the 2. So I want to drop this 2 here. So this will be equivalent to k powers 2 minus 3k is greater than 4k. Okay, now I'm going to drop another k on both sides. So I'm going to cancel this k here, and one of the k here. So this will be equivalent to k minus 3 is greater than 4. And, well, if we move the minus 3 to the right side, we have to say k is greater than 7. So, Terrace, if we are following this way, well, the start point will be k is greater than 7. So this is the end there. Starting from k equals 7, we can prove that this is true. Okay, so far is, well, are you okay with this process?
Yes.
Okay, now our job is not finished. So everything on this side is supposed to be on my scratch paper. Because when we are writing a proof, we have to go from the knowns to what we want to prove. So this means this line is supposed to be the last line, not the first line. So this is the scratch side. Now I want to do the final proof side. We want to start from k greater than 3. Oh, sorry, k greater than 7. Okay, if k is greater than 7, this means k minus 3 is greater than 4, right? So if k minus 3 is greater than 4, this means k minus 3, I'm going to multiply a k on both sides, is greater than 4k. And this means k squared and my k squared minus 3k is going to be greater than 4k, is greater than 4k. Okay, and then after that, well, I'm going to try to add a 2 here, because when I'm adding a 2 on the left side, it will make it even bigger. So I want to add a 2. So this will be k squared minus 3k, and then plus a 2. Because I'm adding 2 on the left side, it will make the left side even bigger. And after that, I want to change the left side to k minus 1, k minus 2 is greater than 4k. So I'm just reversing what I've been doing. Now I'm trying to multiply. On the left side, I want to multiply a k minus 3 factorial. So I'm making the left side even larger. By making the left side even larger, I'm making the left side even bigger. And for this part, I'm gonna rewrite the left part as k minus 1 factorial is greater than 4k. Okay, so I'm building starting from the k greater than 7. Now I'm building toward what I want to prove, which is k plus 1 factorial is greater than k plus 1 cubed. So what's the next part? I want to multiply k on both sides. So k multiplied by k minus 1 factorial is going to be greater than 4k squared because I'm multiplying k on both sides. And after that, this guy becomes k factorial is greater than 4k squared. Now I want to make the right side smaller. By making smaller, I mean I'm going to make it 2k squared, and then it should be k squared, and then plus 2k, and then plus a 1. So I'm making the right side even smaller. So it is guaranteed k factorial is greater than this guy. So the right side, it will be k plus 1 squared. And then if I multiply k plus 1 on both sides, so it will be k plus 1. And then of the k plus 1 plus k factorial will be greater than k plus 1 cubed. And that is what I want to prove. K plus 1 factorial is greater than k plus 1 cubed. So on the left side, it is what I would do on the scratch paper. And after that, I have to reverse everything. So this is what I start from the k is greater than 7, and eventually I can prove k plus 1 factorial is greater than k plus 1 cubed. So this is just the exercise on tweaking the math to make sure that the two sides can cancel something on both sides to make it easier, and eventually we reduce it down to something we know it is definitely true, and then we reverse the whole process. And the thinking is just like this one. So if we have Dr. Sang and Bob, and then if I want to prove that Dr. Sang is fatter than Bob, we reduce things from Dr. Sang. We add things to Bob, but still we want to show Dr. Sang is heavier. Okay? So I think I'm gonna stop recording